very good morning to everybody. I would like to thank you all for the time and joining us today for Airborne Robotics Photogrammetry Webinar. Today we'll be diving into the equipment, processing and best practices used in aerial photogrammetry. And before holding anybody up, I would like to dive straight into it. First, starting off with a little bit of housekeeping. I'm going to be running through the speakers to start, and then I'll be touching on the agenda. So just to keep everybody in the loop, we'll be recording this webinar, which you can find online across our social media platforms for all those that weren't able to attend and anybody that would like a copy of today's webinar. So without further ado, I'd like to introduce our speakers for the day. First speaker on call would be Alex Frias-Erfeldt. He is the Chief Executive Officer of Air6 Systems and Airborne Robotics. Followed by him will be Rob Clow, the Director of Cloud Geomatics. And then we'll have Simon Adams, the UAV Implementations Manager and Lead Pilot at Airborne Robotics, who will be discussing some of the practical elements of photogrammetry. So for today's webinar, we'd like to try and do our best to keep it within 45 minutes, leaving a little bit of time at the end for some question and answers. So we'll be starting off with the essential definitions of photogrammetry. We'll then be moving on to the requirements of survey-grade photogrammetry. We'll then dive into tools and simplifying the workflow, reviewing of historic buildings and surveys, achievable accuracy, and then we'll take a sneak peek at our future webinar, which will involve photogrammetry and Lidar and the approach to collecting data. So if everyone can look in the left-hand side of their screen, you'll find a chat bar. In that chat bar, there is an embedded Q&A section. So if anybody does have any questions during the course of today's webinar, please feel free to jot down your questions there. And like I mentioned, we will do our best to answer as many of those questions as possible. So for the rest, sit back, grab your coffee, and enjoy today's webinar. Handing over to you, Alex.
Thank you, Keegan. And also hello from my side. Welcome, everybody. I think we have a great panel today, very colorful in terms of national flags. We have got Rob from Australia. We have got Simon from the UK, Keegan from South Africa, and myself from Austria, and a very experienced panel. Before I go into the actual topic, I would like to say a few words on Airborne Robotics. We are a manufacturer of drones with focus on professional applications. In the UK, we have offices in London and Basingstoke. The wider group includes also Air6 Systems in Austria and in Germany. The team has a track record since 2014. As a manufacturer, we design, develop, and manufacture the drones, but we also customize systems and do demonstration services. Our key sectors comprise currently 8 sectors consisting of surveying, power distribution, oil and gas, wind energy, then industrial automation, logistics, agriculture and forestry, which is one of our original sectors since 2014, and then task forces, so everything around the blue light sector. When it comes to the question, how do we perform, there are quantitative measures and also qualitative measures. On the quantitative side, we have got a flight time up to 60 minutes and a payload capacity of 10 kilograms, which is very respectable for small rotor drones, but also our redundancy feature and what we call splash water resistancy. So you can fly the drones in light rain. We don't recommend to fly in heavy rains, but you can fly in light rains. Now that we are talking about the topic of surveying and photogrammetry, what matters for us is accuracy, which includes precision and spatial resolution. Then system and sensor integration, which is very important to have a smoothly functioning turnkey system, and also workflows which integrate hardware and software. We've mentioned redundancy, which is essentially an enhanced fail safety for the drone. So all the essential electronics are twofold. In case one fails, there's a second one available. And then power reserve, so wind and weather resistance. Our systems typically have 65% power reserve. It's very important in harsh weather conditions. when the drones have to even out and balance out continuously, that they have enough reserves to actually perform the tasks they have to do. And then last but not least, our open platform architecture, which is very important, so that can integrate for our customers all the sensors and all the best ingredients on the market according to their wishes and orders. Here, a quick wrap up in terms of our product range, which consists of 5 rotor drones, starting on the left side with the smallest, which is the Air 4 Nano, sub 250 grams, typically for tactical recon, also for research purposes. The same for the Air 4 Lite, which is the drone next to it, sub 2 kilograms, is a very light training, but also research copter. And it can be used for indoor flying, so it is able to fly in GPS denied situations, or a mix of GPS and GPS denied. Then we have the Air 4 and the Air 6. Those are mid-sized all-rounder drones for inspection, photogrammetry, and also agriculture and forestry. So that's a mid-sized version, typically in the range up to 6-7 kilos maximum takeoff weight. And the difference between the Air 6 and the Air 4 is that the Air 6 gives you some kind of redundancy through the 6 rotor and motor combination. And then we have our flagship drone, the Air 8, which is also used for today's webinar. It is used for either medium-sized ranges or medium-sized payloads up to 10 kilos, and can also be used for a combination of different sensors. Here you see a Lidar system from Regal and different, in this case, 3 RGB cameras, 2 on the side and 1 in the back, which you can't see. All in all, up to 10 kilos. The drone can do more than that. It can go up to 15 kilos, but the recommended weight is up to 10 kilos. Here, just another look at the Air 8, which has been used for the data collection of this webinar. It's a universal payload platform, again, for either heavy or multiple payloads and larger distances. So you get quite a good flight time for a rotor drone here and very good payload capacity. Flight duration for photogrammetry, in this case, it's about 45 minutes with the setup of the cloud PPK and the Sony a6000 camera. And then with slightly heavier Lidar systems, for example, you get a flight time of 35 minutes. It's very stable, weather resistant, and as I said, fully redundant, which might be very interesting for those of you who are flying in confined spaces, who are flying in built areas, so that you have an extra item here, and a very important item to argue for your safety case and your specific permission. It's quite flexible in a sense that it has a retractable landing gear for filming, for example, and it has foldable arms for compact transport. So the transport case which comes with it is about 70 by 70 wide and long and 60 high, so it fits in any compact car in the back area. So going into the topic, what is photogrammetry? It is a technology which is already over 107 years old. It was discovered around 1850 and originally conducted via hot air balloon and later on with airplanes. So looking at the period after 2000, that's where it became a bit more feasible because of the digitization development. The next push it got around 2014 with drones becoming, let's say, a bit more mainstream, drones being used in surveying purposes. And that's where we had back then developed our Air 6 drone. Moving on, the Air 8 drone is just a bigger drone, which is more versatile, which came in around 2017-18. And in terms of type of photogrammetry, there are 3 systems we are looking at today. So RTK, or real-time kinematic, basically in the early days, 2014-15, it was used. This was then developed to PPK. That's came in at around 2018 and is the preferred choice typically today. So that's a process which is not in real time, but post-processed. And then we have a feature which is PPP. precise point positioning. It's something which has been in the market for quite a while, but it has been now developed to the standards of today's surveying, and Rob will talk about that in a minute. Then we have a layer of accuracy, well, up to 2000. That was quite a broad range of accuracy. From 2000 onwards, it was sub 10 centimeters still with airplanes. And then in 2015 with drones, we achieved much better accuracy with RTK. We're talking about sub 5 centimeters. That has been since then improved with PPK to sub 3 centimeters. That's more or less what we are promising, but it can be better. Some of the results, some of the surveys I've seen, they are even below 1 centimeter. Then there's another layer, which is convenience. So with the introduction of RTK, we basically were able to abolish the ground control points. So there's two things we should also clarify. So we have ground control points, which would be in order to achieve accuracy. So those are not needed anymore. What we are still doing, we are establishing at least 1, 2, or maybe a few more checkpoints. And checkpoints are really to actually check what the real accuracy achieved during a survey is. So it has nothing to do with achieving it. It has more to do with checking what's the result. So no ground control points anymore. With PPK, we don't need any live link, so LTE or GSM or whatever, to the reference station. And then with PPP, we basically don't need any reference stations anymore because it's a system which is provided automatically via a global course network. So you can see with improving sophistication and technology advancement, everything becomes more convenient, it becomes more accurate and easier to handle. Just here as a last point, what is actually photogrammetry? I'm sure most of you know it, but we are basically having a set of overlapping photographs, and through the process of triangulation, you can determine any point in the space if you have the relative distances as displayed here on the left side of 3 points in the space. So you can calculate force. And obviously, that's not a mathematical thing that you have to do. That's all done by the software which is provided. So that leaves me with a few more definitions of terms. So we have said it's RTK, PPK, and PPP. RTK has the advantages in real time, but it's slightly less accurate. And you have, as it needs to be a permanent link to the virtual reference station, it's a slight fragile construct. So that's the advantage of PPK. You don't need this permanent link. So you do it in a post-processed workflow. And so it's more reliable, it's more robust, and the accuracy is also better. So we are looking at less than 3 centimeters, excuse me, of accuracy here. And then PPP, and that's why I hand over to Rob. I think that's one of the USPs of the cloud system, to be able to also bring in the PPP service if required.
Yeah, thanks, Alex. Yeah, so I will just explain a little bit about the PPP part, because you're possibly quite familiar with PPK. It's quite a common thing now with photogrammetry and drones. PPP has been around for a long time, and typically was about, better than half a meter was good, around 0.1 of a meter. You had to wait an hour to get that accurate. But the latest technology here is quite amazing. So we have Novatel military grade GNSS boards inside our system, which is on the Air6 drones. Because we're at that highest level of hardware, working with Novatel, which is a Hexagon company. Hexagon also tied in with SmartNet and TerraStar. Their latest products, they call it RTK from the sky. So it applies precise satellite orbit and clock corrections, but then it also ties in SmartNet stations all around Europe. So effectively, you are getting to that RTK, PPK accuracy without any base station. It doesn't matter about the range to a cause station. That's a limit. With RTK and PPK, you do need to be within, say, 30 Ks. So PPP will work anywhere in the world, but particularly in most of Europe, North America, Australia, New Zealand, Japan, a lot of countries where those other ground stations are tied in. It is a very spectacular result. The processing algorithm is a lot more robust, and where we find often customers will be traditionally using PPK post-processing and that things come unstuck, they're not getting the accuracy they need, then this new PPP, sort of hybrid PPP, PPK processing is more robust, more accurate, and works with less, you don't need to think about base stations. Where's your cause data coming from and all that?
So moving on from here, with the remainder of this webinar, we focus on PPK. And we want to be informative here in this webinar, and that's why we have given you some of the details on the slides beforehand. But most of it you don't really need to know. It's just for you as a background information. What you need to know is that the PPK process is a direct georeferencing process, or DG. So the accuracy is computed by the exact and high-end GNSS technology and data, and also the knowledge and calculation of the precise center of image coordinates from the camera. And there is no other surveying equipment required, so you don't need any base station to survey any checkpoints or any control points, and there are no ground control points required at all. So all you need, and all you need to know, is you need to have a drone which is up to the standards of the surveying grade photogrammetry process, which delivers you the images from the aerial images and also the PPK file to the cloud software and the cloud hardware. And then secondly, you need correction data from a VISO course. Typically, this is provided in RINEX file format with an accuracy of 1 centimeter. I will come back to that in one of the next slides. And then you have the cloud processing software. So basically, the software gives you the chance to upload this data, images, PPK file, and also the PPK correction data. And then you get an output, which are accurate coordinates and the camera calibration data. And with that output as a text file, typically, you can use that information and data to do post-processing in third-party software that you might have or which you might choose. So this slide gives you an overview of all the ingredients we need for photogrammetry process. So we have talked about the UAV, so it needs to be a suitable UAV for the planned mission. So that requires flight time, payload capacity, but also other things like you need to be able to set the camera angle either 90 degrees or whatever you choose. And it needs to be tied in. So the triggering needs to be tied in with the mission planning software, the triggering of the camera. Yeah. Secondly, and I would like to ask Rob to talk to that on the camera. What are the specifics for the camera?
Our objective here in doing photogrammetry is taking photos to create an accurate survey grade model of the terrain or buildings, whatever you're trying to survey. It all comes down to the camera. The camera is your core central component. So Sony cameras are brilliant for their size and weight. They are best quality cameras you can find. And with a high quality lens on a Sony, and also we can calibrate that lens or guide you through a process to calibrate your lens. You're starting out with the best quality inputs going into your photogrammetry, and that's what it's all about. And that's how we can approach that claim of saying you don't need GCPs. So that traditional way of having GCPs and reverse engineering camera positions and lens focal lengths and all of that goes away. So not only your engineering, it's a forward engineering process with quality data, and it actually makes your life easier because the processing will happen in half the time with quality data. So yeah, great cameras.
So the next point is you need to have a mission planning tool which is suitable for photogrammetric needs. There are a few points I would like to mention here. For example, terrain follow can be very, very handy. In particular, if you want to have stable GSD. So, for example, the terrain is very undulating, and you have, I don't know, 100, 200 meters level of rising in the terrain. So you want to keep the drone at a stable distance to the ground. And that only works with a terrain follow mode, which should be there. And then you can achieve consistent GSD. The other thing is also that you want to have a drone which doesn't have a practicability restrictions. For example, some of you might know if you go with consumer drones out into the field and all of a sudden you get a message that you have to do a software update. So you don't want to have that. It can be very cumbersome. It can be very time costly, etc. So you don't want to have that, and you also don't want to have no-fly zone restrictions. When we do photogrammetry in a survey grade, let's say quality, we assume those are professionals on the case and they know how to get flight permissions and where to ask and when to ask. So this consumer grade no-fly zones and restrictions are not good for a professional service. Okay, then I would like to hand over to Rob again with regards to the GNSS system.
Yeah, thanks, Alex. So yeah, as we mentioned before, with PPK or that hybrid PPK process, you can determine very precise, very accurate, absolute accuracy on your camera center for each photo. So this comes down to getting the very precise timing of each photo. Also, the cloud PPK system is integrated into the drone. So we're capturing the tilts of the drone for every click of the photo. So we can correct from the antenna to the center of the camera, no matter, what attitude the drone is in at that precise moment. So that's your core data for directory referencing, is nice quality camera, calibrated lens, and knowing exactly where that camera is for each photo.
Then point 5, we have listed here photogrammetry software. So this is basically a third-party software. So after you have collected all the data, after it has been post-processed, you can feed that data into, for example, Argisoft or Pix4D. Those are the typical software used in the market, which we can also provide with the turnkey system we provide. So that's where you can then do your display options and run the data through and do whatever you need to do. We'll come back to that on a slide, go through the most typical steps on it, but that's something which is also to be considered as within the workflow. So the workflow summarized here would be the mission planning. So you plan your mission, typically desktop in the office. So you prepare before you go out. You can do it in the field. So our systems are equipped with a tablet, Android tablet. So you can either do the mission planning in the office, or you can adapt or do it from scratch, even out in the field. And then the mission is uploaded to the drone. Before you fly, you establish at least one checkpoint. That's not a control point, so it's just for checking your accuracy at the end. So you don't need a base station for that. You just take your drone, place it above a target, and trigger 1 or 2 images. And then you're good to go. You can fly your mission. We will see this on the slides further down the presentation. And then after the flight, and that's where I hand over to Rob again, there's some processing to do.
So in step 4 there, we're looking at our base station options. So you can download from a cause station in your vicinity. There's a few listed there. You might be operating your own survey grade receiver on site. A lot of mine sites and so on, or construction zones, will have their own base station, or you can use the PPP option as well, which is, a no base station option there. So that all happens in our desktop software on that step 5. So brings together your base station, your rover data, produces those. Precise means kind of relatively accurate, but relative to each other. But with absolute accuracy, you're producing all of your camera center coordinates. And then taking that into your photogrammetry processing, Pix4D, Agisoft Metashape are very popular. They're context capture, capturing reality, a lot of other software packages as well for photogrammetry. But I guess just probably to reiterate a bit on that, how we're breaking away from tradition and old method of putting GCPs all over your site, and you might need a dozen of them, you might need 20. If you're using those smart ones, you got to go and put them out, then you got to go around the end and pick them all up again. I don't think it's that smart. What we're doing here is with direct georeferencing, knowing your camera parameters, all those lens distortions and so on, and knowing where the camera is, it's like forward engineering. You're taking good, clean data in, producing your photogrammetry, and then, as Alex mentioned about point 2 there, if you can have a couple of checks on your site, you're not using them to rubber sheet your data and stretch it and make it fit. You're just saying, okay, on my checks here, I'm seeing that I'm within 2 centimeters, 3 centimeters, 1 centimeter, whatever. There, you're measuring how well you are measuring. So that coming from a surveyor is a more solid process. It's an forward engineering process than the traditional GCP approach. So you'll get better quality outputs. Your processing will be half the time as well, because it's not trying to reiterate and find out where the cameras might have been. So it's faster, more convenient, and more accurate. It's the only sensible way for surveyors and engineers to work.
All right, so over the next slides, we're going to go a little bit into the practical side of things. And Simon, over to you to talk us through the process.
Hello, everyone. Yep, so we've got a mission planner here. We're just concentrating on the building. So in terms of this flight, we did a cross section here, and you can see that by the yellow lines. That's the path of the drone as it flies over the house. You could set up a flight plan if you're in a very large area where the drone just goes backwards and forwards. But in terms of the data that we wanted to collect for this building and for the drone to cover all aspects of that building, I used this crossover here. So there's lots of information that Mission Planner will give us, the total area. So you look at the bottom of the slide there, the total area, distance that the drone is actually going to fly in the mission. The number of pictures, that's all worked out for us as well, with the information that we're putting into Mission Planner, because we're telling it about the drone, we're telling it about the camera, and it can calculate all this for you. And it will even give out at the end there a minimum shutter speed. And for this particular model that we made, I think I had it at 1/600, and it says a minimum shutter speed there of 1 to 568. So there's a lot of information that you as a consumer can put into the software. So in the top right-hand corner there, there's a couple of tabs, simple grid options and camera configuration. So in this case, as we've mentioned before, we're using the Sony A6000. We're flying at an altitude of 90 meters. You can dial in the angle of the camera, particularly for this flight. We actually kept it pointing straight down at 90 degrees. And we're flying at a speed of about 5 meters per second. So here we are in front of our mission target, if you like. So the whole mission is then uploaded via the connection on the Air 8. There's confirmation of that. Now in this particular location, because of the trees, I took off manually. I've done the flight checks that I need to do with the Air 8 and got it roughly into the start point. And then I then handed Mission Planner the controls of the drone, if you like, and on off it went. And you can see in the bottom left-hand corner there, the drone in live time, where it is in mission and when it's taking a photo. So as a consumer, as the operator, it's really quite handy to see all this sort of data live when you're actually doing it. Then return to launch. So there we go, a 4-minute flight, and there's our 48 images. So we use Agisoft. There's a workflow within Agisoft, which is pretty straightforward. There's a few things that you need to set up within the software. But the first thing you do is load all your images up. Now, obviously here we only had 48 images, so the processing time didn't take a vast amount of time. But these 6 processes are quite important to get your ortho mosaic at the end. And I would suggest that your client will want the ortho mosaic. And there's various desktop programs that are free out there for your client to interrogate the data. Because I would suggest that they probably haven't got Agisoft. But we've got the point cloud there, the dense cloud, the 3D model. Now, the 3D model, when you look at it in that state, is a really good indication of the quality of your model. Once you've got that, you can then add the textures, and that really brings that model alive. The DEM there, the GPS data, you can see all the elevations, the contours, a great model, again, data that your client is really going to be interested in. And then ultimately there in number 6, there's the ortho mosaic. And this is what it's all about. So we're on about that distortion-free and true to scale image. And that is what our ortho mosaic in Agisoft will give us.
Originally, we planned to do a combined survey, Lidar and photogrammetry, but we figured out it's just so much information for one webinar. So we have decided to split it up in 2, and we are just giving here a little bit of a sneak peek for what is coming up. And the reason for doing this follow-up webinar is that we have received more and more inquiries over the last, I would say, 18 months, in particular from professional organizations, from big organizations, power lines, etc., asking, for surveys in both Lidar and photogrammetry at the same time. And this might not be so relevant for a building like this, where you have a 4 to 5 minutes photogrammetry flight, but this might be much more relevant, for example, in power sector and power lines, where you have, let's say, a survey of 20 kilometers, which you have to split up if you're restricted to visual line of sight. And then the time can add up quite quickly when you have to do separate flights for photogrammetry and also for Lidar. And that's why we will be presenting the solution for that. So when you combine photogrammetry and Lidar, you basically have the combination of the best of both worlds. In terms of Lidar, it's a fast data collection process because you don't require any data overlap. And depending on how high you fly, typically your surveying corridor can be easily 100, 150, 200 meters. And you have also a bit more detailed depth information, in a sense that with the Lidar, you have different returns. So you might have the first return, which plots the points on the surface. So for example, the tree canopy. And then the second return might be the ground. So you have a ground model as well as the model of the surface. And that can be very valuable information, in particular when it comes to, for example, power lines, or the construction of rail, or the construction of cable cars. So you can collect quite a bit more information here with Lidar. On the photogrammetry side, as you might be able to see from this image, and don't be confused about the resolution here, because we had to reduce it for the purpose of this webinar. The image is like photorealistic mapping, and you can get a real digital twin here. Can be produced from different sensors. So the typical sensors we would use are RGB, thermal, multispectral, and it includes this clear and visual information, which might be very important for construction companies, power lines, but also for researchers. So with that said, I think we have come to the end of our presentation, and I would like to hand over to Keegan again for opening the Q&A session.
All right. So, Alex, thank you very much. Also, would like to thank Simon and Rob for being with us and sharing all that they know about photogrammetry. I found it very insightful myself, and I hope everybody else did as well. Very interesting to hear about the different techniques and the accuracy data that is required, and how one can go about setting up data capturing through photogrammetry. So there is one question asked, and I will try to do my best to phrase it as best as possible, but ultimately the question is posed: is there anything that can be said about defense and security roles, in brackets, policing at home and military in war zones, with regards to the role of AI and deep learning to enhance the value of data analytics? if anybody feels that they would be open to answering that question or sharing a little bit of knowledge that they may have on this topic, feel free to raise your hand and go ahead.
Yeah, I mean, I would say this question is really going beyond our webinar. The webinar here is to address surveyors and maybe the construction sector. Photogrammetry is used also very strongly in mining, and I'm sure Rob can say a lot about that as being from Australia, but also for digitization of historical buildings, etc. So there's lots of use cases for that. Frankly speaking, we get from time to time inquiries from the blue light sector, so police using photogrammetry for certain tasks to fulfill and getting a good overview from a site, for, let's say from a, either traffic or from a accident site. So we don't have any specific views on how photogrammetry can be used in the military sector. Rob, have you got any experience on that?
Look, my only comments would be typically with that sort of surveillance thing, it's less about accuracy and generating models, but it's a quick, you want quick data. And also you're mentioning AI there, which is sort of, different. So accuracy does come into inspection and so on. If you want to inspect the same thing twice, you want to be able to find the same rusty bolt. You don't want to have two different models in different places. So there's that. But yeah, really, I guess one thing we're working on that touches on military is our Lidar systems and doing real-time Lidar georeferencing, which is kind of an R&D project we're into right now. But that would be more of your military application where you can fly over something and immediately know what that situation is. So, but yeah, not exactly a fit with what we're talking about on accuracy and photogrammetry, I'd say.
Okay, thank you very much. I think that does kind of direct the answer to the question. So it seems that it's a bit off the scope for today's webinar. We do have another question that has come in. What were the different returns Lidar provides? This may have been mentioned a bit earlier, but the returns, maybe speaking about the difference between Lidar and its data output in terms of the quality of its data.
Let me start with that and maybe hand over to Rob if you want to add something. So the typical Lidar system, which is used in the market, would have two returns. So that would be the first and the last return. So the first would be, as I said, the tree canopy, so the cover of the tree, so that you get the shape of the tree, for example. And then the second return would be the most solid one, which is the ground. So that you have basically a 3D model consisting of looking at the tree, for example, you have the cover of the tree, all the leaves, etc. And then you have returns of the trunk and the branches, for example, and then the ground. And what you can then do, you can, for example, strip out the first return and have only the last one, which is the ground. So that's the typical scenario. But you have higher quality sensors, which might have more, even unlimited returns. That depends on what you're choosing, and it might also affect the weight of the payload you're choosing. So if you have a standard 2-return system, you can get away with below 2 kilos nowadays. And otherwise, you might have a bigger system, which is probably also used in manned aviation. But Rob, over to you if there's anything to add.
Yeah, and I'd agree with that. Some of the Lidar units we're testing now or working with from Ouster and Hesai are very high quality, and at a typical drone range, yeah, you can have maybe 3, possibly 4 returns. I think that's the real definition on the returns in Lidar. But then the way that question's phrased, I'd also comment on you end up with 3D points in space. You also get a reflectance level. If you scan a piece of roadway, you'll see most of it's black, but the white lines come up bright as can be. They're often the Lidar scanners will pick up infrared as well. So then you can do analytics on vegetation with raw Lidar. Well, that is an infrared component that will come into it. So you typically get infrared, you get reflectance. Colorization requires a camera with your Lidar. so that you can then match pixels to points on your LiDAR points. So then you get that realistic, natural colored point cloud. And then that's before even getting into classification, separating out power lines, trees, ground, buildings, cars, people, etc. So loads you can do with billions of dots.
Thank you very much for those answers. We are running short of time. There is just one last question that I think we may be able to address. Simply put, how is LiDAR and photogrammetry integrated together, or are they separate entities?
Well, again, I let also Rob to comment on that, because he has been working on that topic quite a bit, also in the manned aviation, so with larger systems. So first of all, the LiDAR process is somehow already naturally integrated, because typically nowadays when you produce a point cloud, this point cloud is actually black and white, and in order to colorize it, you have to have a tool to colorize it. So you're making basically sets of images, and it can be images, or it can be also a 360-degree camera which takes a video, and from that video you basically get the colorizing, and that's basically your first step towards this combined process. Rob, why don't I hand over to you, because you're much more of an expert on it, so maybe there's something to add.
Yeah, look, I guess I won't add too much, but the photogrammetry process on its own produces point clouds in order to align all the photos. So you'd need at least a sparse point cloud to do photogrammetry. Then you typically produce a dense point cloud before you create an orthophoto and a terrain model. So you'll get point clouds from photogrammetry, but yeah, if we're talking about LiDAR plus photogrammetry, then yeah, there's a lot of different levels that it can come together. And having a LiDAR surface to put your photogrammetry onto as well can speed up processing and create better results. So it is a big, complex topic. I'll just go back to the accuracy point though. If all of your inputs are high quality and accurate, then all of these different data types come together quite nicely. If they're not, then it's a monkey puzzle of stuff. So you know, that I'll just bring it back to the accuracy point there.
There are no more questions. I think we've done a fair chance in answering all the questions in the time we have. Okay, so yeah, without holding up anyone any longer, we'd just like to thank you all for joining us today, and I'd like to thank the speakers again for your time and answering those questions, as well as sharing all the knowledge that you had on photogrammetry. I would like to express to anybody that does have any questions or follow-ups, feel free to reach out to the event organizer, myself, or there is our contact details there at the bottom of the slide that's on the screen at the moment. If you have any questions, feel free to ask. Otherwise, yes, this is obviously one of many webinars that we have in session. So please keep your eyes peeled and posted on our social platforms for upcoming webinars. We will more than likely be hosting a LiDAR combined with presentation with photogrammetry in the not so distant future. So keep your eyes posted and peeled for that. From my side, thank you very much all for your time. It's been a pleasure sharing this fantastic presentation with you all, and we hope to see you again in the future.